Ok, hola, buenos días. Yo soy Trent Biggs. Yo no quiero que ustedes sufran con mi pobre español de Duolingo. Entonces yo voy a hablar en inglés. Uh, Gracias por su paciencia. Um, Okay, I'm a hydrologist by training. I've been studying mostly the sediment issues and the water quality issues along the US-Mexico border. And we have done a lot of field work in Mexico, in Tijuana, to understand sources of sediment and water pollution. I think we're almost here. And it's only through the work of my collaborators on both sides of the border that this work has been possible. So thanks to all the collaborators who I've worked with, and it's so nice to see familiar faces and new friends. I'm going to give a very broad overview of the Tijuana River as I and my colleagues understand it. There are experts in the room who know much more about specific aspects, and I look forward to learning about those aspects from you to improve my understanding. So the Tijuana River is divided into two parts, not by the border, but by dams. So there is a blue area that contributes flow to the four big dams on the river, the Rodriguez, El Carrizo, Barrett, and Morena. So there's dams on both sides of the border that capture runoff from the upper part of the watershed. Those dams impound 75% of the basin area, and water runs off from those watersheds on both sides of the border and provide fresh water to both the United States and Mexico. It's only about 5% of Tijuana's water supply. So it's a relatively small amount of water, but we also need to protect the water that's coming from that basin. So a resource that comes from the basin that we don't often think about is sand. So not only water, but also sand is important for our regional economy. Sand comes from the entire basin and deposits in our beaches. That's why our beaches are here, is sand from the river. The same dams that are providing water are also capturing almost all of the sediment from the upper basin. And so the dams have reduced the sediment supply by 50 to 75%, which is contributing to beach erosion on both sides of the border, requiring expensive nourishment. So when we think about water, we also have to think about all the things that water carries with it, not only contaminants, but also beneficial constituents like sand. The third resource I'll talk about is the Tijuana estuary. It's the largest remaining estuary in the United States, in Southern California. It's an important biodiversity hotspot and nursery for fishes. Unfortunately, the Tijuana estuary has the opposite problem of the beaches. It has too much sand in the wrong places. This is a map of the elevation change in the estuary from 1986 to 2005, showing lots of sediment accumulation. Let's see, with a laser pointer. No, that's fine. So a lot of sediment accumulation up to 15 feet in the southern end. And so the beaches don't have enough sediment. The Tijuana estuary has too much sediment in the wrong places. So I'll talk more about how we might address that problem as well. So those are the resources, then the hazards. I'm going to talk about wastewater, flooding, and erosion, and associated wastes. So all of those hazards originate in the part of the watershed that straddles both sides of the border. It's about half in the United States, half in Mexico, and includes all of Tijuana. That's the active contributing area of the basin. And that's where all of the wastewater, the flood flows, and the erosion happens. So I'm going to talk about wastewater first. I want to carefully separate wet weather wastewater from dry weather wastewater. So dry weather wastewater is what has been in the news, and I'm going to argue that it's a sudden, significant, but very solvable problem. So this is from a recent study on the associated air quality impacts that have occurred along with the dry weather wastewater flows. But I want to emphasize that as recently as 2021 and 2022, there were almost no dry weather flows in the Tijuana River. Zero. It was almost totally dry. We installed an instrument in October of 2022. It was bone dry. There were no flows. So the flows that we keep talking about with closures of the beaches for more than 1,000 days, et cetera, that all started very recently, suggesting that it's also a very solvable problem. And in fact, the problem has already, in terms of the flow in the dry season, in dry weather conditions, the flows have already diminished significantly from 50 million gallons a day to around 10 in the Tijuana River. And so I'm very optimistic that this problem will be solved. And we should start thinking about wastewater not as a hazard, but as a resource. And the treatment plants at Arturo Herrero and La Morita treat 7 to 12 million gallons of water per day that discharge directly to the Tijuana River. And that's 14% of Tijuana's water use. So MIT 328 funds is providing funding to pipe the treated wastewater from Arturo Herrero and La Morita and put them back in the Rodriguez Dam for future use. And there are people here who would know much better than I do about this project, and I look forward to hearing more about what you know about this project. Especially those from CESP who have helped study this as an alternative. Another opportunity is decentralized wastewater treatment plants. So not just at the 2 big treatment plants, but in the neighborhoods that don't have sewage collection. There's an opportunity to turn some of the wastewater into a resource for wetlands, for vegetation, for cleaner water. And one of the examples is Ecoparque, which is in Tijuana. I highly recommend a visit. They collect wastewater from the neighborhood. They treat it in wetlands and turn it into a resource. And this is studied by my colleague Natalie Mladenov and her colleagues here in Mexico. So that's wastewater as a hazard and a resource. Next, flooding and storm flow more broadly that also originates from this downstream of the dams. This is a flood that happened in the Tijuana River estuary in January of 2024. And I want to emphasize that it's not just the water, but also the contaminants in the water that are a problem. And we might ask, how have flood sizes changed in the Tijuana River over the last 50, 60 years? Happy to see Napoleon here in the audience. This is work that Napoleon from UABC and Ensenada and I are doing to plot the time series of floods, the maximum discharge, which is what I want you to focus on, or the annual peak from 1962 to 2025. And there are 2 things that you should observe. One is a long-term trend. So flood sizes have increased by at least a factor of 10. The other thing to observe is that there were some very large floods from 1980 to 1996 associated with El Nino years. So there's a long-term trend, but there have been bigger floods in the past, and we can expect and need to prepare for even bigger floods in the future, right? So this is something that we all need to be ready for, is bigger floods superimposed on top of the long-term increasing trend, right? And we believe that most of this increasing trend is from increasing urbanization and increasing impervious surfaces. So it's also possible that these large floods are smaller than the ones that happened before the dams went in. So it's very likely, we think, that these large dams had even bigger storms and bigger floods prior to the Rodriguez and Barrett dams being installed. So it's nothing that the estuary and the coast haven't seen before, but it's something that recent human settlements haven't seen before. Okay, I'm going to talk about that later. So erosion and waste is another problem in the Tijuana estuary associated with the active contributing watershed. Here's a neighborhood in Tijuana where we've done some work to quantify how much sediment is coming from different erosional processes. And you can see this is a clear hazard for the people living in the watershed. There are communities at risk. It's not just the estuary that has a sediment problem. It's the communities who live there and the people who live there that are at risk. Here's another example. This is a picture taken by Napoleon of a neighborhood where there is an unpaved road. The erosion undercut the water supply pipes, and the water distribution system collapsed and generated a gully that's 5-7 meters deep. So this is a connection. I want to make connections here between erosion and water supply. On the sort of marginalized periphery of Tijuana, there are a lot of neighborhoods like this. Unpaved roads that get undermined during big storms. The water infrastructure supply, the water supply fails due to catastrophic failure of infrastructure. So this is another potential area for win-win solutions, where reducing the sediment load to the Tijuana estuary from these small side watersheds could also benefit the residents by stabilizing the surface, by improving the water supply. And I think this is one of the main problems affecting residents in Tijuana related to water. Okay, so there's an opportunity then, we think, to have a three-pronged approach to understanding remaining issues with storm flow, sediment, and flooding, which is a combination of advanced monitoring, remote sensing, and modeling. And there's websites for each one of these. I'm going to talk about each one of these in sequence. So one of the things we can do is monitor wastewater, not by having to get a sample out of the river and analyze it for bacteria, but by having proxies that, like what's something called tryptophan-like fluorescence, or TRP. And that's a sensor that we have in the lab, where you take a water sample, you run it through this machine, and you get a reading on what's called tryptophan fluorescence. That's on the x-axis. The y-axis is the amount of bacteria in the water. And we've tested this with both storm samples and dry weather samples. And there's a pretty good correlation between the fluorescence, which is easy to measure, and the bacteria, which is hard to measure. So we're going to use this to monitor the success of the new wastewater treatment and capture programs that are currently being implemented along the border. So we're very excited that we're in a position to monitor how much the river is improving with the increased investments. We also have a sensor that you can deploy in the water to sense tryptophan. It's not quite as good as the one that's in the laboratory, but for individual events, it can still document how much bacteria varies during an event. Okay, so that's one opportunity going forward, is advanced sensors to monitor water quality in real time. Another one is remote sensing. So we have installed what's called a hyperspectral camera. Most cameras use 3 wavelengths, red, green, blue. This measures hundreds of wavelengths, not just 3. And we can see from laboratory experiments that the camera response changes as you increase the amount of wastewater. And we've documented that satellites can see these same wavelengths of light that can allow us to map the sewage and detect wastewater with a camera. And this camera is mounted in the Tijuana estuary. It's collecting data today, along with one of our fluorescent sensors. And so we're working to correlate the measurements in the water with the camera with a satellite, so we can map changes in water quality without having to go to the field to collect a sample. Another new technique that we're using is radar, and radar can see through clouds. This is very useful in the coastal area where it's very cloudy. This data is available every few days. And one surprising finding is that the big hotspot for plumes is not the Tijuana River. It's actually the outlet of the San Antonio de los Buenos wastewater treatment plant. That's where we find the most plumes from the satellite imagery, suggesting that water quality in Mexico is, and along the coast, is probably highly impacted by some of those plumes. We need to better understand what is the water quality along the coast in Mexico, because that's the place that's probably the most highly impacted by some of these plumes. So we really look forward to working with partners here in Mexico to document water quality and its relationship to our remote sensing, which suggests that there are significant plumes in both places. So the next step after monitoring remote sensing is modeling. And this is a model of and forecast of water quality in the region put together, includes Mexico, put together by UC San Diego. And there's a website here, you can check it out. It provides a 2-day forecast of what water quality is along the coast, including in Playas down to Rosarito. It's this kind of real-time forecasting tool validated with the remote sensing and the monitoring that I think is going to allow us to avoid public health impacts of any continued wastewater problems. The other type of modeling is with floods. This is a project modeling floodwater depths in the Tijuana estuary. And they've documented where the floods are going to be above your head, where they're going to be above your waist, above your knees. And this same model has been applied on the Mexican side to Los Laureles Canyon and the Tijuana River. And those flood maps are available for those who are interested so that we can prepare for the big floods that are almost certainly going to occur. And so one thing that I am really excited about is our Big Ideas collaboration that was funded by SDSU to collaborate across the border. We had a meeting in Tijuana in 2023, I think it was. And it includes partners from SDSU and all throughout Tijuana and Mexicali. It's called the Water Across Borders, Agua a través de las fronteras. And we look forward to continuing to meet that group. We're going to meet at the Border Conference in Mexicali in October. And we look forward to seeing, I look forward to seeing many of you there. So we want to continue to further expand the network. And I want to acknowledge the efforts by the One Coast, One Community group, and note that there are Also complementary activities being done by Margarita Diaz's group and Natalie Modanov. They have a different focus. They're calibrating laboratories for measurements of tryptophan for wastewater characterization. And we look forward to working with everyone who has an interest in maintaining a safe and economically vibrant community. So the conclusions: the Tijuana River is a resource, a hazard, and an opportunity. The easy hazard to address, I think, is the dry weather wastewater flow. I think we're already have made big advances there. And there's an opportunity to not only to turn that hazard into a resource through wastewater reuse. Harder to address is the erosion in some of the marginal areas of Tijuana. I think there's a significant opportunity for win-win solutions there. And the hardest to address are going to be the storm-related wastewater and floods, because big floods are hard to prevent. You're better off preparing for them and being ready. Restoring the sediment supply to beaches is also a very difficult thing to do. So the conclusions: there's a need for continued monitoring and warning systems. We need to understand how will water quality along the coast respond to the forecasted reductions in wastewater from the new efforts to treat the wastewater that's currently in the river and at Punta de los Buenos. How will floods continue to change with climate change, with increasing storm frequency? How will that impact water quality? We don't know. How will that impact sediment delivery to the beaches? We don't know. Should we intercept floods with grain infrastructure? How would that impact the estuary? How would that impact our beaches? And just closing, I think there's a real need for regional partnerships, building trust, and that starts here and starts with these kinds of events. So thanks to everyone for being here, to the organizers for the invitation, and look forward to talking and learning from you. Thanks.